Alright guys, this is Miss Johnson here. I am going to be recording your Unit 8 Notes 1. This is our first video for Unit 8. We're talking about simplifying radical expressions. Our objectives today are to find the prime factorization of a number, to simplify a radical expression, and to simplify a radical expression with variables. So those are the things that you can expect us to be doing, and those are the things that you should be able to do by the end of the unit. All right, so first let's revisit the concept of perfect squares. Perfect squares means we have an integer and we're going to square it, and the result is a perfect square. So if we go through and make this list, these perfect squares are going to be really useful for us today. They're going to be really helpful when we're starting to prime factorize these numbers. So if I go through and make this list, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. And I can keep going and make my whole list. So I want you to see if you can pause the video at this point and finish off the perfect square list. All right, so here's my finished off list of perfect squares. And again, these are going to be really helpful for us to recognize when we start simplifying radicals. So let's just look at what a radical expression is. Actually, let's go back. We need to simplify or do the prime factorization of the numbers that we missed there. So if I'm going to do the prime factorization of 63, I'm going to take 63 and I am going to break it down into a factor tree. I'm going to find its two factors, or find two factors that I can split it into. One option might be 9 times 7. And then I keep going until I can't break it down anymore. So I can break down the 9 into 3 times 3. 7 I can't break down anymore. 3 I can't break down anymore. So this is my prime factorization. That's my list at the end there. If I look at number 2, 98, I'm going to break 98 into 2 times 49. 2 I can't break down anymore. 49 is the same thing as 7 times 7. And then the 7s I can't break down anymore, so that's my prime factorization list. For 180, there's a lot of options you could break 180 into. You could do 2 and 90. I did 18 and 10. That's one thing to note about prime factorization, is that no matter which way you start breaking it down, your end result should be the same. So you may break it down a different way than I may break it down, but when we get to the bottom, we should have the same list of factors. So I did 18 and 10, which gives me 9 and 2, and that gives me 5 and 2. 9 I can break down into 3 and 3. 2 is just 2, 5 is just 5, 2 is just 2. Now typically we list these things in order. They ended up being in order for 63 and for 98. So I'm going to go through and I'm going to list out all of these factors in numerical order. 2 times 2 times 3 times 3 times 5. Okay, so there's my prime factorization of 180. Now let's take a look at what a radical expression actually is. A radical expression is just an expression that has a radical term. So any expression that has a radical sign, and for those of you that haven't heard that word before, the radical sign is what we've called in the past the square root sign. It's actually called a radical because we can have different roots. We can have cube roots and fourth roots and fifth roots and so on. We're mostly working with square roots, so that's typically what we'll look at. But just know that that symbol is called a radical sign. So that's where a radical expression comes from. It's any expression that has a radical sign in it. Now, there's three things that we have to watch out for when we're simplifying radical expressions. The first one is we can have no perfect square under the radical. We're not allowed to leave a perfect square under the radical sign. The second one is there's no fractions left under the radical. I can't have a fraction left over. And the last one is I have no radical in the denominator of a fraction. Okay, so there's different things that we have to do in order to simplify all of those problems. Let's take a look at the properties of radicals. This is straight back from Unit 3 when you guys looked at exponents and how they work. Same type of deal here with radicals. If I have the radical of the square root of AB, it's the same thing as the square root of A times the square root of B. So for example, if I have the square root of 10, That's the same thing as the square root of 2 times the square root of 5. I can break that apart. I'm allowed to do that. Also, if I have the square root of, let's say the square root of 20, that's the same thing as the square root of 40 divided by the square root of 2, because 40 divided by 2 is 20. Okay? And then the square of a square root. If I take the square root of 2 and I square it, look at what happens. We all know that squaring something is multiplying it by itself. I'd have the square root of 2 times the square root of 2. That gives me the square root of 4, and we all know that the square root of 4 is 2. So in an essence, the radical sign and the square canceled each other out. When I take the square of a square root, I cancel out the radical sign and I'm left with just what was underneath, which in this case is a 2. Now all those things are going to help us simplify radicals today. Let's take a look at number 4 on the back of your notes page. I'm looking at the square root of 50. Let's break down each of those numbers. Okay, I'm going to do the prime factorization of those numbers. So for 50, I'm going to break it down into 5 and 10. Now what I'm looking for is a pair of numbers under the radical. Just like I had in the last slide, where I had this square root of 2 and square root of 2, anytime I get this pair, like I have two 2's here, I can take that outside, just like it happened here. So if I look at 50, I break it down into 5 and 10, then I can break the 10 down into 5 and 2. The 5 is just 5. Now check it out. 5 and 5, I have a pair under the radical. Anytime you have a pair under the radical, I can remove them and bring one outside. So a pair underneath makes one outside. So I can bring the 5 out front and make it the square root of 2. Another way we could have thought of that is the square root of 50 is the same thing as 25 times 2. And we all know that the square root of 25 is 5. So I'd be left with a 5 outside. I'd still have that square root of 2 behind. Same answer. So there's lots of different ways to think of these things, and it just depends on how we're looking at it. But we should all end up at the same result. So if I look at the square root of 48, I'm going to break that down into 4 and 12. Okay. Then I'm going to break the 4 into 2 and 2. I'm going to break the 12 into 3 and 4. I have one more thing to break down. 4 is 2 and 2. This 3 comes down, that 2 comes down, that 2 comes down. And now I look for my pairs because again, these are all under the radical. So if I'm going to look for pairs, I have a pair here that's going to come out front. I have a pair there that's going to come out front. So here's what I have. I have a 2 out front from that pair. I have another 2 out front from that pair. And I have a 3 left over underneath because the 3 didn't have a pair to come out with. So I have 2 times 2 times the square root of 3. 2 times 2 is 4. 4 square root 3. I want you to pause the video at this point and see if you can work on number 6. Now, if we look at simplifying fractions that are underneath the radical, remember we're not allowed to leave any fractions under the radical. We're also not allowed to leave any perfect squares. So I have to get rid of all of those things. I can't have a fraction under there. So let me break down these numbers. It helps if we see the prime factorization of both of them. So for 75, I'm going to break that down into 5 and 15. That's the same thing as 3 times 5. This 5 is going to come down alone. For 300, I'm going to break that down into 30 and 10. That 30 is, we could say 5 and 6. 5 is 5, 6 is 2 and 3. 10 is 2 and 5. Those are already done. And now I'm going to make my lists. This is the same thing as the square root of 3 times 5 times 5 over, I need all of these factors there. 2 times 2 times 3 times 5 times 5. So now let's see what we can take out. This pair can come out in the numerator, this pair can come out in the denominator, and that pair can come out in the denominator. That's the same thing as 5 square root 3 over 2 times 5 times square root 3. Now, check out what happened. Square root of 3 divided by the square root of 3, we know that any number divided by itself is 1. So I can cancel it, I can get rid of it. Same thing with 5 over 5. So I've canceled the whole top, leaving me with a 1. My answer here becomes 1 divided by 2, or 1/2. That's the most simplified version. So there's yet another representation of 1/2. Okay. Let's try number 8. In number 8, I'm breaking down 32. So 32 is the same thing as 4 times 8. That's 2 and 2. That's 2 and 4. 4 is 2 and 2. And again, I'm just doing the prime factorization there. 5 2's under that radical. 50 we just looked at. For 50 we had 5 and 10. That was 5. That was 2 and 5. So 2 times 5 times 5 is my list there. Okay, so if I look at all of those together, I have the square root of 1, 2, 3, 4, 5 2's. And in the bottom, I have 2, 5, and 5. Now let me find what I can take out. I can take out this pair of 2's. I can take out that pair of 2's. This 2 is alone, so I have to leave it. On the bottom, I can take out that 5. So look at what I have left. I have 2 outside times another 2 outside times the square root of 2. And I have a 5 outside times the square root of 2. But again, we all know square root of 2 over square root of 2 goes away. If I simplify what's left over, that's 4/5. Okay. I want you to pause the video at this point and see if you can work on number 9. Let's talk about simplifying radicals with variables. The same principle applies. So I'm going to reveal to you what we do to simplify expressions with variables, and then I will come back in a second. So go ahead and pause your video at this point so you can get down your notes. All right, so let's move on and try number 10. Now in number 10, we have the square root of x to the 4th. Now, we all know that x to the 4th is the same thing as the square root of x times x times x times x. That's 4x's there. So now, just like with the numbers, I need to look for pairs. I have a pair here that can come outside, and I have a pair there that can come outside. So when I take that pair out, I have an x out front. When I take that pair out, I have another x out front. I've canceled everything underneath, and I'm left with x times x. X times x is the same thing as x squared, so that's my simplified expression. If I look at 4b to the 3rd, I have the square root of 2 times 2, that's the breakdown of 4, and then I have 3 b's. Okay, so now let me find my pairs. Here's a pair that can come out front, and here's a pair that can come out front. So I have 2b outside, this canceled, that canceled, this is left underneath. So I have the square root of b underneath, 2b square root b. Okay. In number 12, I have 2 variables here, but again, the process doesn't change. I'm going to break down the 75, which we already know is 3 times 5 times 5. And the x squared is, so I have 3 times 5 times 5. X squared is x times x. Sorry, I'm running out of room here. Y to the 3rd is y times y times y. Move this down out of the way. And when I look for my pairs, I've got 5's, x's, y's. So I have a 5 out front, an x out front, a y out front, and a 3y left underneath. And there's my simplified expression. All right, I want you to try number 13 and see if you can you could try number 14 and 15 if you wanted as well. We'll come back tomorrow and finish the rest of your notes. Thanks for watching, and we'll see you then.